Alright, I'm going to be going over the harness modification process for this 2003 5.3 harness. I believe this is a flex fuel harness. I've got my pinouts from, this is the same thing that's available on my website. You can download it in PDF form. Got the C1 blue connector pins, C2 green pins. This will probably be a lengthy video. I'm not going to cut it for time. These seals do like to stick on the computer. These do belong in the connector. There's a groove down in here they belong in. First step, I always do, so I go through my computer connectors, pull out the highlighted wires I can tell you to remove, and I'll uncover this section of the harness between, this was the C2 fuse block connector, and then these are the C150, 152, 153, and that would be your tack module electric throttle control. Nice sharp razor blade. You want to make sure you cut through the tape but don't damage the wires. It kind of takes a little practice to get the feel for it. Also unwrap the main trunk line going up towards the engine just a little bit. Some of these wires will loop back up into here and then run back down. Use about that much. And if you don't plan on using the factory underhood fuse block, there's no need for these connectors. I'll identify all these wires. Half of these are going to be removed, and some will be labeled. Always cut them close to connectors so I can use the maximum available amount of wire. And on this connector, the fuse block plug, I'll connect everything that's not pink. I'll cut everything that's not pink. Eventually we will, just for right now. This will be all the wires for the injectors and coils and O2 sensors, computer, tack module, transmission, all of it. Go and get all this unwrapped. Alright, everything's unwrapped. Finish unwrapping these. C1 connector first. Remove the blue covers. There's a simple white tab. You press down and you pull out a little bit. And they come off. Cover over the back of the wires. This can be tricky to get off sometimes without breaking. Almost always break at least one of them. Alright, there that is. Now each wire has a pin location that's numbered. And it corresponds exactly with my list right here. And you just simply go down the list here. Now this is going to be a swap in an old hot rod. It's just going to be the engine transmission by itself. So the first pin that we're highlighted yellow we're going to come to is this requested torque signal. That would be on a traction control type of deal, where the traction control is telling the PCM how much torque to allow the engine to output. We're not obviously going to be doing any of that. When we remove that pin, you can actually pull all the way off, and because we cut it off all those connectors, we're just going to pull the wire all the way out. Just going to go right on down the list. You come to one highlighted in blue, 19 and 20. This is your key hot, battery hot wires. We've already cut the orange. Now we'll highlight that battery hot. We'll find the pink wire. Trace it back to the C2 block, and now we'll cut it free. And the other orange wire is right here on pin 57, real close, so I'm going to go ahead and pull it out too. And now we can label these. These are the battery hot constant power to the computer. The computer also has, I'll skip ahead just a little bit, there's also a pink wire on pin 75. But I'll do the same thing with it. Pull it, trace it back to the fuse block. And we'll cut it free. And we can label those together. Pick off where we were. $19 and $20. Pin 23 got a low reference, went to the fuse block. This likely went to the fuel tank pressure sensor and the fuel level sensor and the gas tank. So if you happen to be doing an emissions swap where you got to keep any of that, you could keep this. Again, we already cut off the C150, 152, so it comes right out. Pin 25 is the next one, bank 2 sensor 2 low signal. $25. 28 and 30 is a low coolant switch. This would have been the pressurized coolant tank in the fender. It would have just been to send a signal to the PCM that the coolant was low, and then it would send a signal to the instrument cluster and turn the light on. Now these being Rework 2s, these aren't going to come right out. These are going to go deeper in the harness along with the coolant switch. So I'll just pull these wires back out. As far back as we've cut them. If you just lightly tug on them, you can usually find where they are and quickly weed them out. Last one we did was pin 30. So pin 33 is going to be a blue one. That's our TCC brake switch. We'll label it. We've got a pin 38, 39 are yellow. Honestly couldn't tell you what that's for. Damping lift drive signal. I figure it has something to do with stability or traction control, but we don't use it in the swap, so it's coming out. So that's the pink white, pin 38. And pin 39 starter relay control. If you wanted to, you could leave that in there. The computer would supply ground control starter relay. And then there's another pin on here where it has a crank request, and you could let the computer control the starter relay. I don't usually do that. If you're doing a swap into something old, you've probably already got a starter wire. For the solenoid, I just recommend you use it. Both of these will pull right out. So that completes that row. So we'll flip the connector over and we'll start over on pin 41. Being an 03 model harness, this did not have a fan. So we're going to add a pin to position 42. A PCM terminal. These are Mac Tool TCT 1028. Seem to work pretty well with these MetriPack terminals. There's a little rubber membrane there, and usually you can pierce it. That will just shove right through and click into place. We go right on down and we label that. I just put like 5 feet on here. It's really up to you. So we're on pin 43, 44, those are injectors. 45 and 46 come out. Those are 5-volt references. One's for a AC pressure sensor, and the other one's for one of the evap sensors. Likely fuel tank pressure. I don't really know for sure. So the first one, AC pressure, probably won't come out of the harness because it goes deeper in the harness. So yep. We'll just pull this back to there. This one being a 5-volt reference for the evaporative system, likely went to the rear of the vehicle, so it should pull all the way out. It does. Skip on down, 5-volt reference for map sensor, go over to 57 and 58. Continuing on, We just removed the gray from 4546. We've got some blue highlight wires. Need to locate and label. Orange, that's the battery positive I already pulled out in the very beginning. There's another battery positive on pin 20, and I pulled them both at the same time. Next pin is pin 58, dark green class 2 serial data. This is the wire that goes to your diagnostic port, your OBD2 diagnostic port, so you can hook up a scan tool or if you want to tune it later. Sometimes run into people that don't put a diagnostic port on their swap for some reason, and if you ever want to troubleshoot anything, it's almost a must-have. Right next to it is another one that says Class 2 serial data. It was a yellow wire, highlighted yellow to remove. This was a kind of a backdoor communication to the body control module, kind of a dedicated data circuit. We don't use a body control module in a swap, so it comes out. And we'll label this data wire. Continuing across. This O3 harness has an oil pressure sensor on it, and it's available on scan tool data. So if you were planning to use, say, Dakota Digital Dash with a OBD2 interface or some sort of an Android-based scan tool, and you'd like oil pressure to be available, leave the oil pressure sending unit wired in. This particular one, I'm not going to leave the oil pressure sensor. I'm going to pull it out so the customer can use whatever oil sending unit they want that's compatible with their gauge. So that'll be pin 63 is the low reference for that. It's slightly different color highlight here. I think it's a brown color on the website. So it's kind of an optional thing. So we're going to pull it out on this one. And I actually think, looking back, I skipped number 7, which is a 5-volt reference oil pressure. So I'm going to go back and pull that as well. And pulling these pins out, there's a little white tab. And you basically got to pull that tab up, push the pin up just slightly, and then back in. And then as soon as it drops down a little bit, you can push it the rest of the way out, and it pulls out. Flathead screwdriver is all you need. Pull these wires back. We'll run them down later. So we're back to pin 63 we just removed. Next one's going to be 65, which is a purple wire, bank 2 sensor 2. $65. 68 comes out as well. That's the other oxygen sensor signal for rear. And then pin 70 comes out also. That's a brown, it's an oil level switch signal that was used in the factory truck to turn on the low oil level message on the information center. There's no safeties in the computer. It's going to shut your engine down, so there's really no reason to keep this on a swap. There's an optional pin here, pin 71, performance mode switch. This is the same as a tow haul switch. You can add a pin here, and a ground signal will basically switch tables in the computer and use a different shift table for different shift times, different shift pressures, and so on. All programming I do, I enable that function. In the default configuration, that's a function of the body control module. I have one more wire here, which I went and found earlier. It's one of the 2 pink key hots. So that pretty much goes over that connector. I'll go ahead and put these back on. I would recommend going back over and make sure you pulled out all the pins that you intended to. $13, $23, $25, $28, $30, $38, and $39. All removed there. $45, $46, $59, $63, $65, $68, $70. So that one looks good. Now what I'll do before going on to the next one, we're going to tape this back up pretty well the same way it was. So any wires we're going to route. I'm just going to use masking tape because we may have to go back into this if we make a mistake or something like that. So masking tape's really easy to cut off and go back in if we need to. So I take all the wires, route it just like how it was to this bend right here. We'll do the same thing with those. The most important thing is keep the shape of the harness the same. Just going to make sure you don't end up having a wire pulled too tight somewhere later on. There's the completed C1 connector. Brake switch, data wire, battery hot, key hot, and 1 fan control. That should coincide with all the blue highlight. You got a pink and a pink key hot, an orange and an orange battery hot, a green data wire, purple brake switch wire, and we added fan control. Now we'll switch over to the other connector. Just like before, start on, this will be the C2 green connector. We'll start on pin 1 and make our way through it. First pins that come out. Now I've got one highlighted here, fuel pump secondary. You're only going to see that on 6-liter trucks that had dual fuel tanks and they had dual fuel pumps. So that's not going to be, as you see, it's empty on this harness. So our first pin's going to come out. It's pin 5, delivered torque signal. So that's the signal the PCM sends to the traction control module of how much torque's being delivered. If you remember, there was a signal, or a wire on the other connector said requested torque, and they kind of work hand in hand with the traction control system. So again, this is going to come out, and that one should pull all the way out. We've got 2 wires here now, 9 and 10, that are highlighted blue. It's going to be our fuel pump relay control and engine speed or tack signal. So we'll find these. And those connectors we cut off in the very beginning, the C150, 152, that's where all these wires went. And that connector changes a little bit year to year. So it's easier if you just go to the PCM and find these like this, because the PCM stays consistent through all the years. So you don't have to worry about the individual pinout of the C150, 152s and try and track them down there. It's just a little short bit of the harness you got to take apart to get there. So we're going to label fuel pump. On a GM computer, fuel pump control is a power trigger used to activate a relay. Do not hook this directly to a fuel pump. The normal operation of the fuel pump is a 2-second prime when you turn the key on, and then as soon as it sees pulses from the crank sensor, it re-engages the fuel pump. This is the tack wire. The default programming is a 4-cylinder tack signal, and that can be changed in programming to output a 6 or an 8-cylinder tack. Any programming I do, I always set them up for an 8-cylinder output. Moving on, pin 14, AC refrigerant pressure sensor signal. AC on the 03 and newer with the blue and green P59 computer. The AC is there's no AC request wire to tell the computer you want AC in an older swap. So there's really no way to control the compressor clutch with the computer on the 03 up. Now this is an optional. Pin 16 here is a 4-wheel drive low signal. So depending on a 4-wheel drive application, where you have the speed sensor located will determine whether you need this or not. If you have a adapter for transfer case and the speed sensor is in that adapter before the transfer case, you do not need this. If you're running a factory GM transfer case with a 40 pulse speed sensor in the output of the transfer case, you can use this wire, and when you're in 4-wheel drive low, ground this wire and the computer will figure in that ratio. This is not going to be a 4-wheel drive application on this harness, so we're going to pull this out. That went to C153, which was a little 3-pin connector that we cut out. Now we're going to move 18 and 19. 19 is an axle switch signal. I believe this was used so when the front axle was engaged in 4-wheel drive, the computer could send a signal to ABS telling it the front axle is engaged, and it has something to do with ABS and how that functions. I could be wrong. Not needed in a swap, even 4-wheel drive swap. Next we see fan 2 control. So I'm going to add a couple feet of wire and a pin, and we'll add that. Goes in the pin location 33. And when you add these terminals, these covers cannot be on there because that little white tab has to spring out as that terminal passes, so keep that in mind. Alright, that's fan 2. Of course, if you don't have new terminals or wire, you can just use one of the wires you've already removed and slide it in that location and label it for your fan controls. EVAP canister purge solenoid. The EVAP system is, of course, is the part of the emissions system that takes the vapor in the gas tank and burns it. The purge solenoid is the one that's on the intake manifold, green with white, and has a pink wire at the connector on top of the intake. So this wire is going to go deeper into the harness. If you have a vehicle with a charcoal canister, it may not necessarily have emissions requirements, but you may want to keep this if you want to go ahead and just let it burn that vapor and keep that fuel odor smell. Moving on. That finishes 1 through 40. Flip this. 43, AC compressor relay control. .45 is the EVAP vent. This would have been back by the gas tank. Basically, when there's excess vapor in the fuel tank, it just vented it to the atmosphere. Mill control. This is your check engine light. Malfunction indicator lamp is what that stands for. The computer will supply a ground trigger to turn on check engine light. Normal function. Key on, engine off, the light will be on. And when you start it, if no codes are present, the light should shut off. I have found if you shut the engine off and quickly turn the key back on, sometimes the light will remain off. Moving on, pin 49. There's 2 speed signal outputs that the computer will produce. 49 and 50. Basically, the computer is going to read the speed sensor, which is on pins 20 and 21. And that's speed sensor mounted on the end of the transmission. And then it will, based on tire size and gear ratio, it will calculate a 4,000 pulse signal output on pin 50, which runs the cruise box speedometer. And pin 49 will get a 128,000 pulse per mile, which was fed to the analog brake system and traction control system. So typically I'll leave the green-white in there so if somebody can run electronic speedometer or factory GM cluster. If this was going into a swap in a 90s Chevy pickup that originally had analog brakes, you could use this signal and tie it into the original ABS module and retain that. We're just going to keep pin 50 on this one. Alright, next one, 52, 53, and 54 all come out. We have 2 heater controls for rear O2 sensors and a fuel level sensor signal primary. .52, 53, 54. Now on this fuel level sensor signal primary, if you're doing it in the swap, in, say, a 98, 99, 2000 Chevy pickup that had a fuel gauge driven off the data bus, you would probably want to keep this in place, wired to your original fuel sending unit, and then the computer can actually be programmed with that vehicle's fuel level sensor information and then control the factory cluster in the 98 to 2000 trucks. Moving on, 58, 59 come out. 58's oil pressure sensor that we decided not to keep. This is the sensor signal. 59 says crank voltage. What this is if you wanted, as I talked about earlier with the starter relay control, if you wanted to let the computer control the starter for whatever reason, 12-volt signal here will tell the computer to enable the starter. The PCM would send a ground control to the starter relay. '64 fuel tank pressure sensor signal. It's part of the evaporative emissions sensor in the gas tank that actually monitors the vapor pressure in the gas tank. We don't have a 73 here because that would have been for a secondary fuel level sensor. And the last one removed was a black low reference. That would have been a low reference to the AC pressure sensor. If we go back over these, check, make sure we got all the ones removed we wanted to. 5, 14, 18, 19, 34, and we added a wire for the fan. 43, 45, 49, 52, 53, 54, 58, 59, 64, and 80. So this one's done. Just like before, I'm going to tape this up. Just how it left connectors before. And we've got our connectors. And what I'll do is I'll go ahead and lay these back together. We're now done with this PCM pin out. I'll go ahead and plug this back into the computer now so I know exactly how it's going to lay out. Just to hold it there. I'll put these on when we're done. I may have to, you never know. It's a good idea, just leave them off until you're completely done. This is pretty well where the fuse block is going to come out when we get to that point towards the end. The reason I don't unwrap everything here, if you take this whole harness apart, sometimes wires can change lengths and you'll end up having one pulled really tight. So this is all factory length right here. So this is kind of a mess. You just kind of got to work it around and figure out where it'll be with these lengths right here. This may actually work better if I undo this and move it. Got to look to see what looks natural with the lay of the wires. Once you find a way that works, it looks like it's going to lay out all right. I'll take some tape and I'll put a bunch of layers on here so none of this will slide. The way that goes, it also gives you some freedom for mounting the computer. Now really, if you wanted to just make this run in your swap, you could stop right here. You could literally just cut these all off right here. Oh, missed one. You could identify all these pink wires to injectors, transmission, coils, build your fuse block, and you know, basically you're taking apart the entire harness to take these wires out. So it's completely up to you. You could just run it as it is, wire up a fuse block to here. I'll show you a couple more wires. This is our electric throttle module, the Tack module. I'll have to find a new hood for that. That one's a little bit damaged. It's got its own power wire to the fuse block plug. So we'll label it. And then we'll have 4 wires in addition that are for cruise control. Should be a blue, gray, gray, black, and a light blue, I think. Yeah. You'll find a couple of these that just pull out too. Alright, there's our 4 wires going to the Tack module. These are for cruise control. Completely optional. This will be a cruise on signal, set coast, resume excel, and a stop lamp signal. Very easy to wire up if you want cruise. Okay, the rest of these wires here, there's a couple here. Really doesn't matter what they are. They don't go to the computer. They went to somewhere else in the vehicle. We don't really have to worry about them. There is this light green one would be for reverse lights. Remove all that. Use the switch on the transmission. One of these pinks will feed power to it. We'll figure out what it is. Just pulling any loose wire here. it goes deeper into the harness, I'm just pulling it over here with these other ones. This large purple wire is the starter solenoid. You can tie this into your vehicle's starter circuit. It just goes to the eyelet down by the crank sensor for the starter solenoid. There will be a couple black and black-white wires that went here. These are grounds that go to the engine block, and we'll keep one or two of these. There's one for when we build the fuse block and add wire for the diagnostic port. Should be some black-white ones. Where are they? Okay, looks like this harness just has this one ground. So we'll use this for ground to the relay on the fuse block that we build, and for ground to the diagnostic port. Pretty much now what we're going to do, so I'm going to use another piece of tape, since we no longer have to, everything we remove now is going to be from this point back further into the harness. So I'm going to use some more tape right here. And this is all to maintain the shape of the harness. I don't want the harness to just sprawl out and get a big mess. Tape it every few inches or however you want to do it. Again, you can stop here. Key hot to all these wires. Your pink wires over here, battery hot to the orange. Give it field pressure, crank it over, it'll run. Provided security is deleted. These I'm removing simply to clean the harness up. They do not have to be removed. I'm going to stop right here for just a little bit and rearrange the desk.